Hello and welcome everyone. Today we are going to discuss about how to implement a relational database management system right from scratch. For this tutorial today, we will be taking Indian Army as the institution that is going to create its database management system. As my legal advisor advised me to say, and here I'm quoting, this video is solely meant for educational purposes. Before we start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you're new here, then subscribe to my channel and press the bell icon so that you never miss an update. Without any further ado, let's get started. First of all, let's figure out what all we need to do in order to create a fully functional database that suits our needs, Indian Army as in our example. The contents page is going to guide us through this journey as we proceed. Indian Army, as we all know, is the land-based branch and the largest component of the Indian Armed Forces. The primary mission of the Indian Army is to ensure national security and national unity. The ER diagram stands for Entity Relationship Diagram. I know that this diagram can be overwhelming, but I want you guys to take the pain and look closely at the Entity Relationship Diagram. Okay, as of now, let us remember that this is the main diagram that one needs to create before the birth of a database. One needs to map the relationships between each of the entities that will later take the shape of tables, and the relationships will help us to determine the attributes of a particular entity. For improved clarity, I will provide the link to this diagram in the description below. Now, since we're only simulating the situation, we will be taking some assumptions into consideration before going any further. The first among these is that many soldiers can live in a room. Next, soldiers are assigned weapons based upon their rank. A group of soldiers is commanded by a single commander. Assuming the rank of soldiers in the order that is highest to lowest, the order would be this: Field Marshal on top, then comes Major, followed by Colonel, followed by Lieutenant, followed by Sepoy. The soldier with the higher rank can command the soldier with the immediate lower rank. Next we come to the entity sets. Each entity set will later take the shape of a table. Keep this in mind. The first entity is soldier, with the service number as its primary key. Other attributes are rank, first name, last name, age, weight, height, and BMI, which stands for body mass index. Remember that BMI here is a derived attribute. Next entity is quarters, and its attributes are quarter name, max capacity, and number of soldiers currently present in it. Quarter name is the primary key in this schema. Weapons entity has the following attributes: weapon ID, weapon name, weapon type, and barrel. Here weapon ID is the primary key and other attributes give detailed information about weapons. Armory entity has two attributes, namely armory name and armory capacity. Here armory name is the primary key and armory capacity gives the maximum number of weapons it can store. Commander entity consists of commander serial number and commander rank. Here commander serial number is the primary key and commander rank gives us the information about the commander's rank and service number. Room entity is a weak entity set and therefore does not have a primary key of its own. Here room number is the partial key that is used to distinguish among all the entities lying inside the weak entity set. Now we come to relationship set and their cardinality. The first relationship is assigns, which depends upon weapon ID and service number. This is a many-to-many relationship between weapons and soldier entities. This is because multiple weapons can be assigned to a soldier and multiple soldiers can be assigned the same weapon, obviously not simultaneously. Here in the entity relationship diagram, we can see that soldier entity set shows total participation, which means every soldier will be assigned a weapon, whereas weapons show partial participation as all weapons are not assigned to soldiers at a single point in time. The next relationship is stores, which depends upon weapon ID and armory name. Stores is a many-to-many relationship between armory and weapons, as multiple weapons can be stored in an armory and multiple armories can store the same weapon. Here weapons entity set shows total participation as every weapon is stored in some armory, whereas armory shows partial participation as all armories need not store weapons. Lives in is a many-to-one relationship from soldiers to room, as multiple soldiers can live in a single room, but many rooms cannot be assigned to a soldier. Here, soldier entity set shows total participation, as every soldier is allotted a room, whereas room shows partial participation, as all rooms need not be allotted to soldiers. Commands is a many-to-one relationship from soldiers to commander, as multiple soldiers will have a single commander, but multiple commanders cannot command a single soldier. Here, both soldier and commander entity sets shows partial participation because there is a soldier whose rank is field marshal who is not commanded by any soldier, and all commanders need not command a soldier. Finally, there is also a relationship named has, which is an identifying relationship between weak entity set room and strong entity set quarters. After understanding all entities and the relationships between them, we will now convert these into tables. First, we need to understand the most important entity in the database, soldier. As soldier is in many-to-one relationship with both relationship sets, commands, and lives, and total participation is on many side, that is soldier, so in the relationship set, commands, between soldier and commander, the attribute commander serial number will be included in soldier as a foreign key, and in the relationship set, lives, between soldier and room, the attributes quarter name and room number will be included in soldier as foreign keys because room is a weak entity set. Next, weapons is in many-to-many relation with soldier. We get a new schema for the relationship set, assigns, which consists of attribute service number and weapon ID, which are primary keys of the involved entity sets. Weapons is in many-to-many relationship with armory, so we get a new schema name stores with attributes armory name and weapon ID, which are primary keys of the involved entity sets. The entity set room is a weak entity set. While converting a weak entity set from ER diagram to schema, we include the primary key of identifying entity set quarters. That is discriminator quarter name. Finally, we will get this representation of all our schemas and their relationships. I want you to pause the video here and take a closer look at the various relationships these schemas are sharing with each other. Okay, let's move to the next topic, which is functional dependencies. Functional dependencies in relational databases define the relationship between attributes, where the value of one attribute uniquely determines the value of another attributes within a table. As you can see, all the functional dependencies possible in our Army database are listed in this given table. Let us consider the first one, in soldier schema. By knowing the height and weight of a soldier, we can estimate the BMI, hence BMI can be uniquely identified by the knowledge of height and weight. Therefore, this is a functional dependency. Similarly, we can trace out the other functional dependencies in our database. Then we come to the next topic, which is decomposition. Till now, we were only considering the construction of database, which is now ready. But before we hand it over to the Indian Army, we need to ensure that our database architecture ensures data integrity, reduces redundancy, and minimizes anomalies such as insertion, update, and deletion anomalies while enhancing efficiency, maintainability, and scalability of the database system. To accomplish this, we need to decompose the schemas into normal forms. Let's examine each of them one by one. Soldier is in first normal form since the attributes are atomic, that is, they can't be divided into subattributes. Soldier is in second normal form since there is no partial dependency. Since there is a transitive dependency from service number to height and weight, then from there to BMI, we need to split the soldier relation into two separate relations into R1 and R2. Since there is no non-prime attribute defining a prime attribute, R1, R2 are in BCNF, which stands for Boyce-Codd normal form. Similarly, we will check for schemas of commander and room. Next, we check for quarters. Then finally for weapons. So the final tables are as follows. Now we will write the code for creating these schemas. I have taken some random data values to fill the table. First, we create the soldier table. Then we create the weapons table. Then we create the weapons type table. Then we create the biodata table. Then we create the room table. Then we create the assigns table. Then we create the quarters table. Then we create the armory table. Then we create the stores table. Then we create the commander table. Now we come to the next part of our simulation, which is relational algebra. Relational algebra is a procedural query language used to manipulate relational databases. It defines operations such as selection, projection, join, and set operations to retrieve or modify data. In our case, we will be using RELAX, Relational Algebra Calculator, to get response to our queries. The link to this site will be provided in the description below. Now we will start with the queries in relational algebra. The first query will be find the full name and age of the soldiers who are of rank lieutenant. Next, find the names of the armories having the weapon of type assault rifles. Remember that order of join is important when we are performing join across multiple schemas. Find the biodata of the soldiers who live in Quarter 1. Find the names of the armories that do not contain the weapon heckler. Find the service number and rank of the soldiers who are under commanders whose serial numbers are this. Next, we will try to run some SQL queries. For that, go to the official website of MySQL. The link to the same will be provided in the description below. Then download the machine-compatible version of MySQL Server. Install MySQL Server on your local machine. Once that is done, create the tables using the commands mentioned above. Finally, you're good to go. Now we will start with the queries in SQL, which stands for Structured Query Language. The first query will be find the names of the soldiers who can use the gun carbine. Next, find the commander serial number of the commander who commands the soldiers who live in Quarter 1. Find the names of the soldiers who are not sepoy and uses a silenced weapon. Find the age of the oldest soldiers of the ranks sepoy, lieutenant, and colonel. Find the full name, rank, and BMI of the soldiers whose service number starts with letter C. To summarize, this is the Army database, which gives information about soldiers in the Army, weapons used by them, and many more. This will help them to track the availability of weapons, number of soldiers in the quarters, etc. So now, our Army database is perfectly ready to be shipped. If you're facing any issues, do write it in the comment section below. If you liked this video, give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving!